Welcome to episode 273 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing good. So we were without you last week. Did you have a good week off from the podcast?
I did. I was visiting family, which is, sketchy in this day and age, but
Sure.
and now kind of self-quarantining for the next couple of weeks just in case.
Right. Well, it was great talking to Jean Heed and Aaron and Peter, who we had on last week. You all have a reason to actually listen to the podcast for once in a couple of years, right?
Yeah, I need to do that. I haven't yet. I haven't had the chance to yet.
Cool. Okay, well, at the top of every episode, I like to read a piece of feedback. This week, we got a tweet from Gabriel saying, CppCast, have you seen this paper? And he has a link to P0847. Just found out about it from C++ Slack. From the abstract, we propose a new mechanism for specifying or reducing the value category of an instance of a class. And he goes on to say, it looks so nice, it is clean and powerful. And yeah, this is the paper called Deducing This, which I think I've heard about a few times over the past few years. I've never really read into it to understand what exactly the goals of this paper are, but we should probably, have one of the authors on to dig into it maybe.
I swear we had discussed it at some point, but I might just be confusing multiple different conversations.
It's possible we have mentioned it in one of the news articles about different ISO mailings, but I don't think we've ever talked about it in much detail. But I know I've heard about it over the past few years. Yeah. Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Joël Lamotte. Joël is a programmer, game developer, musician, and comics artist, among other things. His software engineer career revolves around game development and embedded software in various domains like robotics. He's a member of the C++ French user group and helps with the organization of CppP. He also tries to participate to the evolution of the C++ standard through feedback on papers. Joël, welcome to the show.
Welcome. Not welcome. Hello.
I noticed you gave us a thumbs up or something at the mention of deducing this. Are you a fan?
Yeah, I mean, I kind of like the idea because it's trying to solve a lot of issues related to, for example, when you make a class and you make member functions and you need, like, it's a template class or just the member functions are templates or anything that is more complex than just one member function. And you need to handle all the variations of const, what was it? With the reference at the end of the line.
Right. Oh, R value and L value and R value reference qualified member functions.
Exactly. And also, like all the variations, and you want to handle forwarding and not forwarding. I mean, there is a lot of situations, a lot of overloads you need to set up to do it properly, in particular in generic libraries. And this kind of help reducing all the overloads to one or two. So it's a very powerful solution, and it's only the way it solves it is very simple. It just gives you the object you are a member of as an argument, and because it's a kind of normal argument, you can inspect if it's const or not inside the function, or if it's there is a lot. All the properties you want to know about the current object are provided to you, basically.
I just found myself wondering, because I've been spending a lot of time with concepts lately, how nicely the concepts with deducing this would play together if you could say, well, for this particular use case, I don't care if it's const or not, but I do care if it's an L value or R value qualified, and then just use like a concept to basically spinning out, eliminate the other overloads there.
You can even like use concept to to filter out some variations of your function in a more specific way because you have access to all the information about the object here. I mean, in principle, I'm not sure because we don't know what we will have in the end, but in principle, it looks interesting here.
Right. Well, it's on version, 4 of the papers that we just linked to, so it looks like it's progressing.
Yeah, it's progressing, but in the same time, because it's not a trivial change, I suspect it will still take some time. So I don't know. C++23 looks like a good target, but in the same time, it's a positive way to see things, I guess.
I'm afraid that this sounds like the kind of thing, too, that could reach a certain point of maturity and then go, oh, well, there's no reason to do this because meta classes will solve this problem. And then...
Actually, I don't think so. I don't think you can solve this issue with any meta programming things because even if you can generate the different variants, what you really want is to write only one, ideally. And you just say, like most of the time, you just say, okay, whatever the situation, just do this code. That's the common case. And if you have to add metaprogramming over it, it looks like a bit like using a bazooka to kill a mustico.
Okay.
So it's possible, but it looks super overkill. So I don't think it will be shadowed by metaprogramming. Although a lot of other issues can be totally destroyed by metaprogramming. Yeah.
Now, I guess for the sake of our listeners, since we didn't actually say what deducing this does really, right? You said you're taking this as a parameter, but so this is a parameter, and it kind of makes our code end up looking like Python in a way, right?
In a way, yeah.
But it's a template parameter, right? It has to be a template parameter, right?
From the last paper, if I remember correctly, it was not the case. So it's not. You can have overloads for the const or not const too, but
okay.
if it's a template parameter, then you have the benefit of doing the choice of what you want to do inside the function, except instead of an overload. And if it's a template parameter, you can also do some things like if it's part of an inheritance tree, you get the actual type of the child, and you can use that. So there is a lot of things that are interesting about this paper because it gives you like all the information you would like to have about the object here. Yeah, it's weird. It's weird because it's unusual in C++. But the basis is just you get the thing as an object, and then the type depends on if you want a template function or not. Because in some situation you actually want a non-template, but you want to do something specific, and you still want to have access to the object in a way that gives you more information than just what this pointer do.
Right. So what distinguishes that first parameter as quote this and makes it a special function compared to just a regular member function? Like how does?
I'm not sure there is actually a difference in the end. So maybe. So I'm not sure about that because of course I'm not one of the writers of the paper. But to me it looks like a syntactic change, a bit like lambdas. Because all the information is already there, so it's just a syntactic change to give you the information. But in the same time, I could be wrong, and it could be like super complex. So I wouldn't be certain about the details here.
So I guess maybe with that much of a diversion, maybe we should have one of the authors of the paper on at some point, Rob.
Yeah, that's what I'm thinking.
Yeah.
Okay. Well, Joël, we have a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about your work with C++, okay?
Okay.
All right. So this first one we have is a blog post about C++20 modules being under review and possibly making it into GCC 11, which I believe is due to land early next year, March to April. So it's good to know they're still working on it. that the GCC 11 like feature deadline I think is coming up real soon. So they're not sure if it's going to make it in, but they're hopeful.
32 patches that add 25,000 lines of new code to the compiler.
It's a lot of code for modules, but I guess we shouldn't be surprised by that.
I actually thought it would be far more, actually. Yeah.
I can honestly say I had no expectation one way or the other. I had no idea how much work something like that takes.
Well, I'm not a specialist in compilers. It's just that I feel like the feature is big conceptually and to implement, but I don't know if it's true. So maybe maybe the implementer should comment on that at some point about how hard it is to implement modules actually.
Right.
It would be ironic that if it had C++ 20 modules already, that it could implement it in only 5,000 lines. No, I'm just making stuff up, right?
It mentions the name Nathan Sidwell in here, so I think he is the primary author on the module's work.
So I
believe so, yeah.
Yeah. Maybe we can look him up too. Okay, next thing we have is this GitLab library called Criterion, and it is a micro benchmarking library for modern C++. And it's another one of those libraries that has a really cute animated GIF in the README showing how it runs the benchmarks and the type of graphs and everything that you get as it's being run. It looks pretty cute.
I believe we've covered several libraries from this author, by the
Have
way,
we?
just kind of coincidentally over the years. I'm pretty sure. Anyhow.
Who is that?
P. R.
Ranav.
Ranav.
Yeah.
Oh, I know Tabulate because Joël Falcou worked on some kind of game recently, and he used Tabulate because it was a MUD. You know what is a MUD?
A MUD, yeah. Multi-user engine.
Yes. So
Yeah.
it was a simple MUD, like an experiment, and he used Tabulate from this person, Pierre Ranav. I don't know.
And I've definitely seen the indicators library for progress bars on the command line,
Yes.
which
I remember
clearly
that
this library makes use of based on that cute
So
GIF as used.
It looks pretty easy to set up, but what I don't know about it is what are the actual features compared to something like Google Benchmark, because otherwise it's very difficult to compare, because when you want benchmark, what you are interested in is more like the kind of fidelity, the kind of precision, the how it does the benchmark, etc. So that's not explained in the README, so I'm not sure what is good about it, except the look. So I wonder, yeah.
Yeah, I also, one of the main things that stood out to me was that the setup and teardown code is really simple to put in here. Stuff that you don't want benchmarked, which sometimes feels like a little bit of a hack in Google Benchmark, because you have to do things like stop clock, start clock kind of thing, whatever it's called, start timer, stop timer. But yeah, otherwise I agree. Like it seems pretty light in documentation, but if you're interested in a super lightweight benchmark tool, then maybe it's something to check out.
Yeah, definitely. Okay, and then last thing we have, another article about compiler support of modules. This one is for Visual Studio, and this is kind of an overview of the support that Visual Studio 2019 now has for modules and how to go about actually using it. It's kind of an overview or tutorial about how to set up modules in a Visual Studio project. It does mention it is limited to MS Build based projects. So if you're using Visual Studio CMake, it's not there yet. But it's nice to see that one of these compilers has full support for modules out now.
It works also with, the previous version too, but it works also with Build 2. And but you need to set a specific line for it to work because the interface have been changed and build 2 wasn't updated since then because it was like last month that Visual Studio was updated. So build 2 will update that, but you can use it at least with build 2 on MS Build, yeah. And I tried it actually, I mean in MS Build, and it works fine. It's cool because I've been experimenting with modules for a long time, and each time I get blocked by something like the compiler crashes. So I report everything, and it gets fixed progressively. But it's the first time I think that I could start a project with that compiler, and it will work. The only thing, I mean, I still know some issues, so I wonder if it will be blocking issues for the kind of work I would like to do. But then, I'm hopeful that I can start like a project in January and go full modules because you can use header libraries. So as long as it's a new project and you are in control of it, like the company doesn't depend on it, I guess you can try that. Yeah. One thing I wanted to mention in the article, I'm a bit confused by the example of code, in particular the one in the part like consuming modules.
Yes.
I think there is an issue there because the code is trying to import a module, but the first line is module semicolon, which is, this line is reserved for when you are actually inside the module or part of a module. And the issue is that the rest of the code doesn't state which module it is. So either it's a copy-paste mistake where they should remove that line, or they forgot to add the name of the module. Because you can import a module in normal C++ file, which is not a module. You know, in a normal translation unit, you can import a module. But if you start a translation unit with module semicolon, it means you are in a module. So at some point you have to specify which module. And here it's missing. But maybe it's just a typo. But it confused me a lot because I was like, maybe I forgot something about the syntax of modules, but so far I didn't find anything that goes against what I just said. So other than that, it's cool. It's just the example that confused me.
Yeah, now that you mention it, that same, just saying module semicolon, it's in a couple of the other samples that are in this. So there's the consuming modules, consuming from other modules. Yeah.
Yeah, those are in my opinion, correct.
Okay.
Because, so for example, if you go under it, there is another example with module semicolon, and then afterwards you have an export module on the name of the module, which basically starts the module. Okay. So this is the correct syntax here. So either you don't have the module semicolon and you start directly with module on the name of the module, or export module on the name of the module, or you have the module semicolon, the includes, and then you export or module the name of the module. Yeah, but I don't believe there is an in between. Yeah. I might be wrong, but so far that's my understanding of the module syntax here.
Yeah.
Do I recall correctly that at some point you were experimenting with modularizing CppScript?
Yes, actually I almost got it right, but I realized that it will be more interesting to. So the way I wanted to do it was mechanically, but I realized that it's a bad idea.
Okay.
You better. I mean, you can do it, but in the case of CppScript, it was not really interesting. It would have been more interesting to just go through the code and transform it manually.
Okay.
But then I got blocked by crashing issues in Visual Studio, in the compiler, which was not complete at the time. I think it was last year or maybe the year before.
It's been a while, yeah.
Yeah, so I regularly try again to compile with them, but I often end up with issues. So this end of year is the first time I'm hopeful at least one compiler is stable enough to try them. Yeah.
Because you mentioned it, it does kind of make me wonder with this Visual Studio support. They're known for doing great refactorings, and I wonder if either Visual Studio or JetBrains might ever have support for change this to a module, right-click modularize. Yes, exactly.
Done.
That'd be great.
What I really need is right-click and convert it to lib format syntax, but that's a different story altogether.
For modules, I think it wouldn't be a one-step operation because kind of the idea with module is to give a specific contour to your module. So you have limits, like borders of your module. It's not clear if it's headers. So you have to kind of specify what is actually part of the module in some way, on what is public and what is not. That's the power of modules. And that's a decision that is hard to do mechanically, except if you do it in like the simplest way, and then a human pass behind to tweak things. Yeah.
Okay. Well, Joël, let's get started talking about the type of work you do in C++. Do you want to tell us how you got started?
Yeah. I started in high school, I believe. Was it? Yes, it was in high school. So we were making games, I was making games even before college. With a friend, we were making games with Visual Basic at the time, because it was just the things that we had available at the time. And one day we realized that the issue of performance we had with a very slow sprite-based animations was because of the language and not because just of the code, and because the language was not optimal for graphic stuff. So we looked at what was used in a real game, I'm quoting with my fingers, like commercial games, which seemed far more fluid than anything we could do. We realized from some gaming magazines that there was a language called C++ that C/C++ that was used in games. There were some examples, but we didn't believe at the time that changing a language could change the performance that much. Because we were young and we didn't know anything anyway. So we made some kind of loop that every second was printing how many iterations it did. On the number of the C++ side via the Visual Basic side was so daunting that at first we thought that it was a big bug, but the loop was doing nothing. So of course it was very, very fast. Right. And when we realized that, we decided to make a game with that, and we made a real-time strategy game.
Wow. You just went straight for a big game.
Exactly. Yeah. From now, like even today, I would consider that difficult to make. But at the time, like we had far more free time, and and we were like highly focused on doing code that we didn't understand was totally a different behavior. So we didn't know better. So that's why we didn't have any limits. So we ended up doing something very weird actually. That was crashing if you quit it. And if you were on Windows Millennium, I believe, it was crashing the OS. So I remember rereading the code like 5 years later on having a big loss because like I was doing some news, calling new, and then free on the object, on a lot of very bad code, but it looked like it was working until you exit the game. Yeah. So yeah, it kind of served me as a how do you call that, a portfolio, let's say. to get some job in programming. Not in video games because that would have needed more skills actually. But at the time, I didn't have any diploma. I still don't have any diploma. So that was my big achievement that I used to get some job at first. Yeah. And it was in C++, so it was impressive for a lot of people. I did not understand why at the time, but now I can see how it was a kind of an achievement. Yeah.
That your story with Visual Basic being so slow reminds me of my first experiment in game programming was in Quick Basic, and I was just trying to draw a tile grid, and I had to manually unroll that grid drawing loop if I wanted it to draw in any reasonable amount of time, which today would just be like, what are you thinking?
That's cool, yeah. Yeah, at the time, yeah. There was also a lot of variation of BASIC that was designed to go around the limitation, the performance limitations. Like I think Dark Basic, a lot of games were made with that.
Mm-hmm.
But at the time, like the best period to learn this stuff, I didn't have any computer at all. So most of the programming, the basic understanding of programming I had was actually on calculators.
Right.
On calculators on computers from friends. So I used like Quick Basic on whatever I had available. And the rest of the time, I was just programming on a notebook, basically. I was programming games on a notebook, and then when I had the opportunity, I would write it on a computer and try to see it. It's helpful for debugging at some point, but a debugger is far more efficient.
So I'm curious now, what you said Windows ME, what compiler were you using then when you were doing C++?
Well, so the first contact with C and C++ was, I believe, with an old copy of Borland C++.
Okay.
Yeah, I believe, because I'm not sure, because I couldn't understand how to use it at all. But I remember I had the CD somewhere. I don't even understand how it got to me. But when with my friend, we got serious about focusing on that game, we actually bought a version of Visual Studio 6.
Okay.
Wow. Okay.
Yeah, Visual C++ 6 to be precise.
Right.
Yeah. And we worked with that. Yeah. So the C++ we learned was wrong. Like it was not standard at all. Like the variables in the for loops were like part of the outer scope. Yeah, there was a lot of things like that. When I learned that it was wrong, I was actually shocked, because I was like, what? There are variants of the language? What the? Yeah, it's but yeah. We started with that, and I think I used it for the longest time until they started to make the kind of free version of Visual Studio that was for education, I believe, or for startups. Mm-hmm. I think it was that. So most of the time I use Visual Studio. It was only in the last 10 years that I was using more than one compiler actually. Yeah.
I think I still have my Visual C++ 6 disks around, actually.
Me too, actually. I don't think you can read it, but I still have it here.
I've always kept mine in a cool, dark place, so I don't think I've gotten any disk rot, actually. So it's possible that mine would actually still... I'm trying to remember. Anyhow.
So that's how you got started in game development. Are you still making your own games these days?
So yeah, well, I'm in a weird place. So I've been making games from far before I was introduced to C and C++.
Okay.
So in the last, I'd say 15 years, I've been working on my side on games that I wanted to make. On my jobs, I worked sometime in the game industry and sometime out of the game industry on some technically related stuff with C++ most of the time. Sometimes with Flash, sometimes with some other stuff like JavaScript. I always have some projects on the side, but the projects on the side are rarely published. Basically, I most of the time I either take too much time and it's not released yet. Like I have at least 2 projects which are paused right now, which I will resume like at the end of the month. And in the same time, I also release sometimes some games, but mostly that I do with some friends. For example, there is a group online. It's kind of a teaching space or service, which is called Home Team Game Dev. So this is a group where basically you, for a fee that is similar to paying a guitar teacher, you get a space where people work on games together. So it's not C++ for some reasons, but the thing is that since I went there, I could better practice the things that were missing, for the skills that were missing for me. Because most of the time when you start a game, you start, let's say it's not a trivial game, then you will do a lot of programming, and the time you spend on programming is not spent on anything else. So you better have a team, but to have a team, you better show something that convinces people to get in your project, in particular if you don't pay them. So on most of my games, I consider a bit weird, and it's very difficult to convey in any other way than with a demo. So most of my games, I got to the point of a good demo, but I didn't show them, and I intend to make some commercial games with that at some point. But in between, I worked on some other games with that group, Home Team Game Dev, which are public and free. So you can play them. There is a link somewhere to my itch.io account, and you can play some of them. There is also some games I make which are actually like present to my friends. Like for example, there was one marriage of 2 friends where I made what we call a visual novel. You know what is a visual novel?
Sure. Yeah, visual novel. Yeah,
Visual novel.
Yeah.
Yeah.
And made a visual novel that was inspired by the way they met, and I gave them as a gift for the wedding. It was nice. And the graphics were all made by friends, because most of the friends were into graphics, drawing. So that's a kind of thing. Like I'm more focused on personal games than games you see in the industry. But at the same time, at some point, I would like to do something commercial, just for the challenge, and also to actually show interesting ideas I have. So we'll see in the future, I guess.
Yeah. And you said professionally, you have also worked on games professionally at companies?
So I worked mostly in small companies, so not so big companies, except one time I almost got into Ubisoft, but there was a crash, and they cut all the projects at the time, so in the end I didn't get in. But otherwise I got into companies that were working on Nintendo DS games. Not really noticeable games. There was some management games. Is that management? Tycoon games?
Yeah, like a tycoon game, sure, yeah, okay. Yeah.
Like a Hospital Tycoon, Hospital Giant on NDS, where I made all the AI, if you can call that like that. Not today, man. I worked on some constrained hardware that way, and in other companies that were not games, so that was for console. And I also worked on some multiplayer games that were on like multiplayer persistent games, but not in the same way you would expect from a MMO. Because it was mostly like the card games that are popular these days. It's kind of games like that looks like jukebox kind of. Not jukebox. The money machines.
Slot machine.
Slot machine.
Yeah, slot machines. Yeah, slot machines. I mean, structurally, it looks like slot machines, but it doesn't look like slot machines because it's just that there is a lot of chance in it, and you only earn stuff that are not really interesting. I worked on this kind of game, so for the technical details, it was really interesting, but I got burned out by like a lot of work to do, and also like morally, I was not happy with the kind of games I was working on in the industry. And when you get in the industry, you don't have a control on the games you will work on. So it's interesting for the technical aspect, except if you are like already popular or something. But I'm more interested in the in this side of things, like authors, like people who want to say something or who want to explore an aspect of nature, of anything actually. I'm more interested in this kind of games, and I would like to like when I'm involved in game development in the last 10 years, it's more related to that than the industry. Yeah. Because in the industry there is a lot of issues, and I don't think I can deal with most of them. So I try to focus on what as an artist I would like to see in games. Yeah.
Okay.
Yeah, it's certainly what we've heard from other game developers in the past, that burnout can be a real issue, which is disappointing. Yeah. You want to take the next question, Jason?
Yeah, so somehow you moved from game development interest into robotics development. I understand you recently changed jobs, but your last job you did robotics development.
Yeah.
I looked at the website. This was SoftBank Robotics. I looked at the website and I'm like, I am so curious about these robots.
I don't think I can tell you absolutely all the details, but there is a lot of details that are public, so you can ask. But yeah, I've been working there for 6 years, which is the longest I've been in a company actually. And yeah, it's very cool. I just needed a change of air, but so I changed the job recently. But other than that, yeah, hello to people at SoftBank, because maybe some of them will listen to this. These robots are pretty interesting because of the social aspects they have. So yeah, this is very interesting. So you asked for how I got in, I believe.
No, sure, or whatever you want to talk about. Your story there is be interesting.
Yeah, it was luck. So it was just like so what you have to understand is that robotics cover maybe a little more different domains than game development, because game development covers a lot of domains that are totally different. But robotics, it's wild because there is hardware. And as soon as you have hardware, you see things a bit differently. But some aspects are similar to game development. So there was a lot of actual game developers in the company. But they needed help from different aspects. So there is a lot of people which are specialized in psychology or robotics itself, or psychology with robots, or like a lot of PhDs, a lot of people like that, and also a lot of people who are just engineers specialized in some aspects of hardware that are used in the robots. And yeah, it's the way I got in was there was 2 years before that where I focused solely on working on one of my big projects. Actually, 2 of my big projects. And part of working on them was working on learning actually about concurrency like in depth. So I spent 2 years just focusing on understanding concurrency and doing some other stuff. Yeah, like with C++ concurrency in action. It's a book.
Okay. Yeah.
Anthony Williams, I believe.
Yeah, that's right.
So I got this. I experimented a lot. I reported bugs to Boost, because there was some issues at some point. But yeah, and I also got familiar with TBB, threading building blocks from Intel. And with that in mind, and a good understanding of type erasure, that was what was necessary to enter one of the team which was looking for people who were good at programming in general. So the team I got in is responsible for the software layer that is used by all the other teams. So the other teams are not specifically C++ developer. They use C++, so they are C++ developer, but it's not their main focus. Mm-hmm. While our focus was actually programming and C++ development, and also inter-process communication. So based on ASIO, more or less. Mm-hmm. So there is a library that you can see on GitHub, which is called libkey. Wow. A Chinese would say libqi because it's the life force.
Right.
Mm-hmm. And that is what is used for inter-process communication inside and outside the robot. The team I was in was working on that. On the library also provides some tools for handling concurrency, and they needed people to understand this kind of issues. Yeah. So basically, I worked on stabilizing the library because it was a bit young and not stable at the time I came in, and added some features missing. So I worked on that, and also on how do you call that? I was trying to solve a maximum of issues in other teams that were related to programming. So I also did some coaching. I guess I'm not sure it's the right term, but a kind of coaching. Or I explained a lot of stuff
right.
to a lot of people. Yeah. But that's the only team that is focused on that. If you look at like the different layers of salaried people in the company, there is a lot of very widely different kind of profile. But in the same time, they are all focused on the same thing. Like you look at a robot, you see it as a one thing. But if I look at even just at the head, I can see the audio stuff are quite complex. You need to understand audio. You need to understand signal processing, and then the visual stuff also is quite complex, but it's a bit different. So it's similar but different. It gets through different hardwares which are handled differently, and then you have to merge them at some point, and then you have to interpret them in different ways, and that's different programs handled by different teams, which need to communicate inside the same head.
Right.
So it's quite complex. So we were basically support for that, like providing all the tooling for that. Yeah.
What does some of the tooling look like in the land of robotics? Is it a real-time OS? Are you able to use the latest C++?
So at the moment, so there is several questions in that. First thing, it's not a real-time OS for this robot. Well, it depends on how you see it. The layer I was in is a kind of a Linux.
Okay.
It's not really a real-time OS from what I understand, because I was not in the team that was responsible for the OS. So maybe there is some aspect of real-time, but I'm not sure. So I will have to ask some previous colleagues. But I believe it is not real-time. So it's kind of a Linux that is driving an Android. So you've seen there is some of the robots have a tablet, like the Pepper one. And that is an Android that is separated. So there is basically two computers communicating, and then the Linux have one process which is responsible for handling the body, and that means it's at least soft real time. So it does have a deadline. I do not. Maybe it's have a special. How do you call that? A special priority or something. I don't know because I'm not in the team that handles that.
Right.
But the teams that handle that made the work so that it's basically soft real time or real time. But then it communicates with other systems which have their own code. So it's hard to explain like in like if it was one system, it's several systems, like cars basically. Like some people say cars are robots basically today. That's true. It's technically there is not much difference except they have wheels. Yeah.
Right.
I mean,
With
they are
modern
only
cars, I
wheels.
totally accept that. Yeah. I mean, how much control do I really have? I tell the car how fast I want it to go. Basically, everything is drive-by-wire now. It has the actual control. Yeah.
And also it's a multi-system system. I mean, there is a lot of not disconnected but connected system that are independent, and that's similar with most robots. Yeah, I'm not sure about all the robots outside of the ones from the company, but apparently from what I learned through the years being around roboticians, is that the way it is done, like if you see the ROS framework, ROS, it's a framework similar to libkey, a bit different in some aspects, but it's what is used by most universities working like robotics courses. I don't know. Yeah, they will use ROS because it's open source and used by a lot of robots. And when you look at how it works, it's basically you have processes, you don't know where they are because it depends on the robot, and each process is communicating with some other process in some way. So yeah, it's a lot of networking. It has to be fast, responsive, and in the same time, it has to be flexible because depending on the hardware, depending on the robots, the specific robots or the model, or there is a lot of flexibility you need. So yeah, it's not really easy to understand without having a big company working on a robot and doing a lot of aspects in several teams. Yeah. So on the programming aspects, it's all C++ with a bit of Python. Because a lot of scientists are more used to Python than C++. So they, for example, libkey have a binding built over Boost Python, which allows any Python developer to do one module inside the robot that could be implemented in C++, but can be also implemented in Python. And there was some discussion about Rust being an interesting thing to implement some modules. Yeah, there was some difficulties related to the communication protocol. I won't get into the details, but basically it's one possibility to have to be in the same situation than how we make websites basically. You know, when we make websites, there can be a lot of services that all implement one feature, but what you see at the end is the client page which requests from different services.
Right.
It could have been like that in these robots, and maybe it will be in the future. So I don't know. But currently it's mostly C++ and a bit of Python. Yeah.
Since you mentioned websites just now, I think you told us before coming on that you're currently doing WebAssembly?
Yeah, so I work at, since last month, I work at, like September, yeah, at jellynut.com, which is totally unrelated to robotics. It's about music sheet, if I pronounce that correctly.
Yes.
I don't know. Okay. Because yeah, so it's about music, so which is one of my passions. So robotics was interesting for me even before I got into robotics. So I was kind of surprised that I could get in a robotics company at the time, and then for a change of air, I decided to go in one of my other passions. So music was interesting too. And yeah, when you go on the website, you can see some music partitions, and it's displayed with a WebAssembly code basically.
Very cool.
And this is C++, yeah. So basically, right now I'm doing the work to update it. I mean, to update its scripting tools, because it was a bit chaotic from like there was a lot of developers who modified a lot of things, and it was not consistent. So I'm working on that. But basically, yeah, it's WebAssembly. So I'm learning the details of WebAssembly. I've been looking at WebAssembly for several years. I think we got a discussion with Jason about that. My interest for WebAssembly. It was like in CppC last year, I believe.
Yeah. Mm-hmm.
Yeah. And yeah, so I'm pleased to have the opportunity to work with WebAssembly, because I do truly believe that it will solve a lot of problems that are not necessarily I mean, it could solve problems that it was not designed for, and I'm interested in that. Yeah.
Okay.
It seems like an exciting opportunity for you to be able to take your interest in music, which we haven't spent, I don't think, any time talking about yet, except in your bio, and be able to apply that with C++ at the moment.
Yeah, it's so that's already a first step to mix both. I actually have I looked at the implementation of the audio proposal. You've heard about that from Tim?
Yeah.
Mm-hmm.
Yeah.
From and I tried to fix some stuff they had in the implementation. So that's my only participation to anything audio. But I intend to fix that in the future. So one of the first steps is, yeah, my day job now imply working with music, because we have a player inside the page. I hope to do more about that, and yeah, it's totally the kind of thing that interests me. Yeah.
So you said that the music sheet rendering is actually being done in C++ and WebAssembly for JellyNote.
But
Is that what I understood?
Yes. So yes, but to be precise, we get a handle to a canvas, HTML canvas.
Okay.
So the rendering is directed by the WebAssembly, but it's actually done through the function of the canvas.
Right.
So it's not like so one way to do it would have been to have some kind of rendering buffer. You draw in it in C++, and
Like
then
WebGL?
that will be again different.
Okay.
But yeah. So the simplest way, let's say you don't have acceleration, and you just have memory. So you just write in memory. You have an image at the end, and then you need to pass the image to JavaScript at some point for rendering. Yeah.
Right.
So you will blitz the buffer, and apparently, so I'm not sure because I did not experiment, but from the notes of the previous developers of my current project, it seems that it was slow to do that. So they preferred to get handle to an HTML object, which is a canvas, and then just call the functions to draw there. Yeah.
Okay.
So I'm not totally sure it's the best way, but that's how it's done right now. On the WebGL way would be to do the same than calling the handle, which will be OpenGL basically. But when you call OpenGL, in the background it will go directly to more or less to the driver, so the graphic driver. So it means that you don't have the JavaScript layer. Well, it's thin, but you try to bypass and get to the hardware directly as much as possible. But it's kind of the same idea than what we have today. Yeah. It's just that currently we don't use the WebGL because we don't need to. Like the canvas is quite good for drawing. It's if you go to my to claim.itch.io, recently I published a game which is all in JavaScript. and it's really all in JavaScript. And I use a web canvas for drawing, and you can see that it's already good for even like action games or things like that. It's 3D enough. We kind of pushed it because we had a lot of effects in we pushed it until it was not good looking anymore. But yeah, I think the canvas is quite fast already. But if you are really serious about doing, like, for example, 3D games, you just need to go with WebGL or some other technology that let you access the hardware directly. I don't know if you can use Vulkan in WebAssembly, but that would be cool.
So
I suspect not.
Sorry.
I was saying I suspect it's not hardware is not accessible from WebAssembly except if you expose an API directly to it. So I don't know how that will work. So yeah.
For JellyNote, do you know, was the primary motivation for using WebAssembly with C++ to like reuse existing libraries, or was it a performance question, or do you know?
So I was not there when it was decided.
Right.
I suspect that it was a performance issue because the kind of work that have to be done before just saying draw a circle, for example, is quite heavy because you have to interpret some complex stuff like music sheets is not easy to understand. I mean, except for specialists like musicians. But it's quite complex to parse and interpret. And the fastest is the best, but we didn't need like real-time rendering,
Right.
because we only render once. And you can see on the pages, if you click on one of the options, it will change the rendering, but you can see that it just like change the image. It's because it has been rendering in the background. So I think it could have been done in full JavaScript, but it was started like 10 years ago, and I believe the performance was totally different.
Okay.
So I think it was a performance issue. Yeah.
Interesting.
So
All
today,
right.
I don't know if it's the best choice. I believe it's an okay choice at least. And also, so there is another reason I mean, it can be discussed, but the code of the player is also used in conversions. Like, for example, if you are a creator and you have a partition, you use a totally different software to make them, and then you output some file like music XML file, which is some kind of standard to describe music, and then you export it, you import it inside the website. And we have to translate it in some way. And it's the same code that reads the player that also translates that converts the file into something that we can work with faster. So basically, on this converter is not at all a web thing. It's like a service, a web service. So it's a backend thing. Because it's a backend thing, it doesn't need to have Node.js working. It could have been implemented with, like if it was all JavaScript, it could have been implemented with Node.js, but it could also have been implemented with just anything. And they decided to go with C++ because like it can work anywhere. So it works too. Yeah.
All right. Well, Claim, it's been great having you on the show today. Since we were just talking about your personal passion of music, do you want to plug your own music before we let you go?
Yeah, well, if you are interested in music made by someone from the C++ community, you can hear all my music on SoundCloud. So it's soundcloud.com/MJKLAIM.
Yeah. I know spelling in a different language is difficult for everyone. Yeah, we'll make sure to have a link to it.
Yeah. Okay. And it's kind of chaotic because I just put music there that I made free. And there is also claim-music.com because I also compose for people. So if you are interested in making me compose for you. You can get there. There is also links to my music there. So yeah.
Very cool.
Awesome.
Well, it's been great having you on the show today, Joel.
Thank you.
Thanks for coming on.